Hello everyone, welcome to our new tutorial video on solving problems from MIT under the course Thermodynamics. That is, from the beginning of this tutorial segment, we are solving problems or challenge problems from MIT. So the problem or the question from this diagram, the question say consider the game of pinball. In this typical form of the game consists of a steel ball of mass m, which is equal to 67 grams, and that is launched up to a table inclined at an angle theta. The table has a length of L, which is equal to 1.5 meter, and its peaks with a launch tract that is measured so that when the ball reaches the height point of the track has zero velocity from the point, the ball starts to roll down the table under the influence of gravity, striking various bumpers and flippers in its descent. The lens is affected by having the operator compress spring that is in constant with the ball at the rest position as shown in figure. The spring is released and the ball begins to move up the table. This is a figure, as we can see that the figure represents the information given above. This is a ball, this is a table, this is a length, is thrown off at an angle theta with horizontal. So they say in this case the spring is a pure translational spring with a spring constant K equal to 110 Newton meter, and its launch position is compressed to 6 centimeter from the free lens position to the operation before the release. Your task is to estimate the value of theta A by taking only the ball as a system, B by taking the ball and the elastic spring as a system. That is a question. So solution, let's go to solve the question. So let us draw a figure to represent the information given. For example, supposing this is the figure, so this is a ball, this is the angle theta, this is the length, this is a height, you can call it height or whatsoever. So you can call it height Z. So this is level 2, that is Z2, this is Z1, this is from here to here, that's the initial position. So this is a ball compressed using using spring. So let this to be the string in the direction of. So this is the figure to represent the information. This is state 1, this is a final position, that is state 2. So let's go directly to answer the question given A. So in A, they ask us to determine the angle theta by using the ball as a system, that the only ball as the system. So let's take ball as the system and solve it, and then we go to B. So now system ball. The system is our ball, so we use thermodynamic strategy to solve this question. So now we solve it step by step. So let's start with steps. So states. So in state we have initial state. This is the initial state. That let's take this as initial state, state 1. This is state 2. So this is x1, that the distance. This is x2. So from the given information, we are given that x1 is supposed to be the opposite to the width or the distance given. That's why we will put minus here. So it's minus, then we convert it parenthesis centimeter to meter, which we have minus 0.06 meter, and then that one from the figure is 0 meter, and from the question B1 is 0. And then state 2, x2 is 0 meter, z2. By considering this diagram, we want to get s2 in terms of L, so we apply trig ratios. So therefore we have sin theta is equal to opposite over hypotenuse, that is z2 over hypotenuse, which is L. By cross multiply, z2 is equal to L sin theta. So here is L sin theta, and B2 is also 0 from the given informations. So then we have interactions. So from the given information, there is no heat in the system, so heat is 0. Then work done. Definitely there must be a work done. If we take the ball as a system, there will be a work done by spring, that the work done is done on the ball by the spring, so the work done is not equal to 0. There must be a work done. So that's the interaction. So now we apply the first law of thermodynamics to solve these problems. So applying first law of thermodynamics, so from the first law of thermodynamics, we know the change in energy of the system is equal to the net heat in the system minus the net work in the system. So from this from the information above, we know the net heat is 0. So the E of the system is equal to the E of the system is equal to minus work net. So we go and determine the work net and substitute. So what is work net? Work net is equal to work out minus work in. This is interchange. If it is heat, if we are dealing with heat, then we are going to say heat in, that is the heat that is coming to the system minus the heat that is going out. So it will reverse in case of work done. So we are going to say work out minus work in, or we put the negative sign here because the sign convention is interchange. So we can say work out minus work in, or we can say is equal to minus into work out, minus work in minus work out. So from the system there will be no work out, only have a work in, that is a work in from the spring to the system, no work out. So work out is 0. So work out is 0. Therefore work net is equal to the work in, that is minus work in, and the work in is from the spring, so it's equal to minus work in and is equal to minus work done by spring, that is a work in to the system. So what is work done by the spring? Then we are going to apply the formula that is the from elasticity, that is work done by spring. Work net is equal to work done by spring, that is minus a half k, that's the constant, into x2 square minus x1 square. So also from the information given, the x2 is 0, that the x2 of the spring, that the final position to which spring is reached is 0. So therefore this will be equal to minus times minus plus, we have a half k x1 square. So we can call this as equation 1. So you can call it equation 1. Then we go back to the original equation and find the total energy of the system. So dE of the system, that is a ball, is equal to the total energy in the system, that is change in kinetic energy plus change in potential energy plus change in internal energy. But there will be no internal energy since there is no change in temperature in the ball, so therefore this is 0. So change in energy in the system is equal to the change in kinetic energy, that is a half m, that's the mass of ball, into b square, b2 square minus b1 square plus mg into z2 minus z1. So from the information given, b1 and b2 are all 0, so this is 0, this is also 0, and also z1 is 0, so z1 is 0. Therefore dE of the system is equal to this is go is 0, so it's equal to mg z2. So this is, we call it equation 2. So now we substitute equation 1 in 2. Therefore, by doing this substitution, mgz2 is equal to a half k x1 square. But from the information determined, z2 is equal to L sin theta, so we substitute mg L sin theta is equal to a half k x1 square. So we make sin theta to be the subject of the formula. From this we know sin theta is equal to k x1 square all over 2 mgl. So since we are looking for theta only, then we take sine inverse of both sides. So we have sine inverse sine theta is equal to sine inverse of the whole expression x1 square over 2 mgl. So this inverse goes with sine, therefore theta is equal to sine inverse of k x1 square all over 2 mgl. So then we substitute the values. Therefore, by substituting the values, theta is equal to sine the inverse of k, that the constants we have, that is 110, then time is minus 0.06 square all over 2 times the mass, that is 1.5 times the mass this is L. 1.5 is a length L, then times a mass for a gram, that is 67 gram, and convert it to kilogram, which is 0.067 times 9.81. By substituting, theta is equal to 11.5 h degree. So that is the value of theta. That is option A. So now option B, they ask us to use the ball and spring as the system. So let's repeat the step by taking ball and spring as the system. So now our system ball and spring. Then we repeat the process. So we have steps. So our states, the something we have x1 is minus 0.06 meter, z1 is 0, b1 is 0, x2 is 0, z2 is L sin theta, b2 is 0. So now our interactions. So no heat, and then work done is also 0, because no net work done, since we take ball and spring as a system. No external work done out, because in the first process we take, spring is not part of the system, so therefore there must be a work done by spring. But for this, beside ball and spring, nothing will do work in the system or outside the system. Every processes are taking place inside the system, that is spring and the ball. So work done is 0 and the heat is 0. So now we apply the first law. By applying the first law, dE of the system, that the change in energy of the system, is equal to work net heat heat net minus work net. So this is 0, this is also 0. So dE of the system is 0, and this dE is the same as the what? dE of the ball plus dE of spring, since they are the system now, so it's equal to 0. Therefore we substitute. For the ball, we have kinetic energy and potential energy, or let's find them separately. So dE of ball, as we did last, is equal to change in kinetic energy plus change in potential energy plus change in internal energy. This is 0. You have only potential and what? Kinetic energy. And then we have the therefore this will be equal to a half m b2 square minus p1 square plus mgz2 minus z1. So from the information given, this is 0, this is also 0, and also z1 is 0. So the A of ball is equal to mgz2, which is equal to mgl sine theta, that is z2 is L sine theta. So that is the change in energy of ball. Then we go and find the change in energy of spring. So dE of spring is equal to the energy due to spring, which is the same as a half K into x2 minus x1 square. So x2 is 0, so x2 is 0, therefore this is equal to a half K x1 square, a half K x1 square. So now we substitute our value. By substituting, we have the E of ball, that is mg L sine theta plus a half K x1 square is equal to 0. Therefore, by collecting the like terms, we have mg L sine theta is equal to minus a half K x1 square. Then sorry, this is minus because this is x1 is minus, so here is minus. So if that is the case, this will be what? This will be minus, so this will be plus. no minus here. So that is minus time. When it is minus here, when it comes here, it will become plus. For example, this. So here is minus. So therefore this is plus. So making sine theta to be the subject of the formula, sine theta is what? K x1 square all over 2 m g l. So making theta to be subject of formula, theta is sine inverse of k x1 square all over 2 mgl, which is the same thing with what we get by substituting the value in similar way we did. Sine inverse is the same as 110 into minus 0.06 square all over 2 times the mass, which is 0.067 times g, that is 9.81 times the length, that is 1.5. so you solve it correctly and substitute, will get 11.58 degree. This means that the angle theta is not a change, therefore our system is not affect the result. The system, or choosing the system, is depend on how we do the analysis. So that is, we take the ball as a system only and we get the correct answer, and also we take ball and spring and we get the correct answer. So that is the magic, how we say, that is the logic of thermodynamics. Thank you very much for listening.